Hi everyone, we're starting our next unit on quadratic equations and quadratic functions, and what we're going to be taking a look at is section chapter 16, quadratic equations. Now, the first thing we'll be looking at today is we'll be looking at how to solve quadratic equations. Now, we've done a lot of work on factorization and finding what the two binomials are that multiplied together will give us the quadratic trinomial and so forth. And now we're going to take all of that information that we've learned, or all those skills that we've learned, and we're going to apply them to actually solving for x. Now, we're going to also talk about in the next few days what solving for x actually means. But right now, what we're going to do is we're simply going to just start by doing the mechanics of it. So let's assume that I had to solve for x in this given problem where it says x plus 5 all squared equals 12. Now, given this problem, the way I would go about solving this is that I need to take that x out of the, or outside of the parentheses that are where it's squared or where we have an exponent. It's raised to the power of 2. So what we do is, because x plus 5 is squared, in order to get rid of that x plus 5 all squared, what we'll do is we'll do the opposite operation, which is square rooting. Therefore, I'm going to square root the left-hand side, and what I do to the one side of the equation, I must do to the other in order to maintain the balance of the equation. So I'll take the square root of the other side. So that I'm left with x plus 5 is equal to the root of 12. Now, when I have the root of 12, I have to keep in mind that it's going to be the positive or the negative version of 12. And I'll explain that in a second, but let's just start by saying that now, in order to isolate for x, what we need to do is we just need to bring that 5 over to the right-hand side of the equation, so we're left with negative 5 plus or minus root 12. So this would come out to be a decimal number, so that we would get x plus or minus, so it would be either. Now, if we want to put this as a decimal, we could, and in placing that as a decimal, what we would have is we would have negative 5, so we would have negative 5 plus root 12, and the other alternative would be negative 5 minus root 12, because remember, we were looking at both the positive and negative version of this. So it would go to negative 5 plus 3.46, or we would have negative 5 minus 3.46. So that we would get our answer on one side here to be negative 1.54 approximately, and on the other side we would end up getting negative 8.46. So the two possible answers that would make the left-hand side and the right-hand side of the equation equal would be either x being equal to negative 1.54 or x being equal to negative 8.46. All right, so just to get back to the question that I was at before, now why do I have, for example, if I take the square root of 4, why does my answer turn out to be the positive or the negative version of 2? Because up until now, we've really said that the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so forth. But now we're saying that the square root of 4 could really be the positive or negative value of 2. And that's simply because if we look at root 4 is the square rooting something is nothing more than the opposite of squaring it. So if I were to take my solution here of positive 2 and square it, well, my answer there would be 4. But if I took negative 2 and squared it, well, lo and behold, my answer would still be equal to 4. So technically, when I do the square root of 4, it could have been a 2 squared, or it could have been a negative 2 squared originally that had gone in. So my answer could be 2 or negative 2. All right, now if we take a look at the second example, I have x plus 1 all squared equals negative 9. Now, in doing this problem, again, I'm going to take the square root of both sides. So this is a relationship where I have a one-to-one relationship. I've got one term on one side of the equal sign, and I have another term on the other side of the equal sign. So in one case, it would be x squared on the left-hand side, and one term k on the other side. Now, when I take the square root of both sides, it's great that I can take the square root of x plus 1 all squared, which is just x plus 1, but I cannot take the square root of a negative number. And I can't take the square root of a negative number simply because there are no two same numbers that multiply together that will ever give me a negative. So, for example, I cannot say that negative 3 squared is going to give me negative 9, because it doesn't. Negative 3 squared just gives me 9, so that's incorrect. So I would have negative 3 squared equals 9, and likewise I would say that 3 squared equals 9. So there is no number multiplied by itself that will ever give me a negative number, because a negative times a negative will always be positive, a positive and a positive will always be positive, and a positive with a negative, well, or a negative and a positive will always be negative. And since we are squaring, squaring means that we are taking the same term. So negative 3 all squared would be negative 3 times negative 3, which still goes to positive. And or it could be 3 squared, or 3 times 3 gives me 9. So it's still a positive. All right. So let's take a look at, that pretty much covers section 16A. Now, if we take a look at section 16B, 16B is dealing with what we call the null factor law. So we actually have a law. And what the law basically says is this, that when I have the product of two or more numbers that is 0, so if the product of two numbers, such as a times b equals 0, then at least one of them has to be equal to 0. So if ab equals 0, then really I can say that either A is going to equal 0 or B is equal to 0. Okay? So let's take an example here. All right. So if I had, for example, let's take a simple example such as I'm just trying to think. I'm trying not to knock the microphone down. I'm thinking of some examples that could work, such as possibly if I did I don't know, 3 times x, or 3x. Let's do 3x times x minus 5. So let's do 3x times x minus 5 is equal to 0. All right, now if you notice, we've got 3x being multiplied to x minus 5. So what the null factor law says, that when I have the product of two or more terms or numbers, when the product is equal to 0, then one of these two solutions, at least one of them, has to be equal to 0 as well. So that I would have either 3x being equal to 0 or x minus 5 equaling 0. And when I solve here for 3x equaling 0, I'm going to say that x is equal to 0 divided by 3, which tells me that x is equal to 0. So that's one of my solutions here. And if I find now x minus 5, so I can, if I do the x minus 5 equaling 0, well, I bring it to the other side, x equals negative 5. So my solution could be either x equals 0 or x equals negative 5. I could have two solutions to this problem. So x equaling negative 5. Okay, so that would be two solutions. So let's take the example that I have above here, the 2x squared plus 6x equaling 0. And what we have is, we've got, we can remove a common factor first, okay? Or rather, I'm not going to use this example yet. Let's look at this next example. I've got 4 times x minus 5 minus x all squared equals 0. So what I have is either 4 is equal to 0, or 5 minus x all squared equals 0. Well, this definitely can't equal 0 because 4 doesn't equal 0. So that's out as a possibility. It's not even an x equaling anything. And then we've got 5 minus x all squared equaling 0, which means that I take the square root of both sides, and the square root of 0 is just 0, and then 5 minus x equals 0. The square root of something squared cancels out those two operations, so that I end up getting 5 is equal to 0 plus x, so that x equals 5. And therefore my solution is x equals 5. Now, if I want to do some other examples, some other examples could be, let's take a look at the next 4 examples, but let's look at f. So I've got f here where I've got 2x multiplied by x minus 5. So what I want to do is I want to do either 2x is either equal to 0 or x minus 5 is going to equal 0, because I'm using the null factor law that says either a is equal to 0 or b is equal to 0 if they are multiplied to each other. So when I make 2x equal to 0, I then isolate for x so that I get x is equal to 0 over 2, where x equals 0. So that's definitely one of my answers. Okay, and one of my answers is x equals 0, and therefore on the other side I'm going to have x is equal to 5 as my other solution. So my 2 possible solutions to this question could be either x equaling 0 or x equaling 5. Now, if I take a look at, let's look at E. So I could have either 11 is equal to 0, x plus 2 is equal to 0, and x minus 7 is equal to 0. These are all multiplied to each other. Now, 11 equals 0 doesn't give me anything because 11 does not equal 0. But x plus 2 equaling 0 allows me to bring the 2 over to the other side and isolating for x so that x equals negative 2. And if I have x minus 7 equaling 0, well again, I bring my negative 7 over to the other side and I get x equaling positive 7. So my answer is either x equals 2, negative 2, or x equals 7. All right, let's take a look at another example, such as C, where I've got negative 5 times 3 minus 4x. So either negative 5 will equal 0, or I can have 3 minus 4x equaling 0. Well, negative 5 definitely does not equal 0, but negative 4x equaling negative 3, bring the 3 over to the other side, allows me to then isolate for x so that I have x equaling negative 3 divided by negative 4, which becomes 3/4. So my value of x will be equal to 3/4. All right, my last example here is negative 4 is either equal to 0 or 2x plus 1 all squared equals 0. Well, this doesn't allow me to get anything, but if I now take because I've got 2x plus 1 all squared, if I take the square root of both sides, the square root of something squared cancels out the square root and the squared, so that I get 2x plus 1 is equal to 0, and now I just isolate for x. So I isolate for x, and I get 2x is equal to negative 1, and x equals negative 1 over 2. All right, so that my answer then would be, here in this case, it would be x equals negative 1/2. We're starting now with section 16C, which is solving by factorization. Now, what we've done so far is we have just figured out what our possible values of x could be when we have one side equaling another side. All right, but now what we have is we can factorize. So in factorization, which should all be very fresh to you at this point, what we can start doing now is we can start solving for x by either removing common factors or using sum and product or maybe using difference of squares, depending on what the question is asking. So if we take a look at the first example we have here, x squared minus 5x equaling 0, before I can solve for x, I'm going to remove a common factor on the left-hand side of my equation first, which is x. And what I'm left with is an x minus 5 inside the parentheses. Now what I have created here now is a situation that is the null factor law. This is either let x equal 0 or I let x minus 5 equal 0. Therefore, my solution is either x equals 0 or x equals 5. And I have figured out that the numbers 0 and 5 will bring my entire equation here balanced to the left-hand side equaling the right-hand side. Now, some people might say, and this is the part where you need to be very, very careful, well, why can't I do this? X squared minus 5x equals 0, and x squared equals 5x, and then I just divide both sides by x, and I end up with x is equal to 5. All right. Well, notice what happens here. This is going to be called illegal cancellation, because in order to be able to isolate for x, all the x values have to be brought over to one side of the equation. I cannot cancel out just by saying divide one side by x, divide another side by x. Everything must be brought over to one side so that I have x squared minus 5x. Then I remove a common factor, and then from there I can use the null factor law. Now, like I said, when I have an x squared on one side, or an x on one side, and an x on the other, I can't just divide both sides by x and say, ta-da, there's my value. My value of x equals 5. Notice that we have part of the answer. So we have the x minus 5 and the x minus 5 here in the first method that we used. But notice that in the first method that we used, we had x equaling 5, but also x equaling 0. So that means that in doing the illegal cancellation, you are missing or you are eliminating one of the possible values of x. So that if you don't do the correct factorization process, where you bring everything over to one side of the equation and set it equal to 0, or set it equal to some number, then that means that you are doing illegal cancellation and you're missing one of the possible solutions. Now let's take a look at the second example here that says x squared plus 4 equals 4x. Well, like I said, if I've got x squared plus 4 equals 4x, the first thing I want to do is I want to bring everything over to one side. I definitely want to bring all of my x's over to one side, so that I'm going to end up with x squared minus 4x plus 4 equals 0. Now, I've set everything equal to 0, because then we can use the null factor law and say either this equals 0 or that equals 0. But when I look at this problem over here, I've got a quadratic trinomial. And the quadratic trinomial tells me that I could be using either perfect squares, or I could be using sum and product, since my value of the a in this case is equal to 1. All right? So since it's equal to 1, it's either sum and product, or it's going to be a perfect square. As it turns out, it is a perfect square, but you can still use just sum and product, so that I can say what two numbers multiplied give me 4, but those same two numbers added together give me negative 4. And those are going to be x minus 2 times x minus 2 is equal to 0. So negative 2 times negative 2 gives me negative 4. That's my sum in the middle. And if I do negative 2 times negative 2, that gives me a positive 4 here, my value of the c. Now, I have it written out as x minus 2 times x minus 2. So using the null factor law now, which is ab equals 0, I can say either x minus 2 equals 0 or x minus 2 equals 0. I don't need to write it out twice. Once is sufficient. So I know that x is equal to 2 or x equals 2. Well, writing it once is just enough. So we can say, therefore, the answer is x equals 2. Now, if we had, for example, the next one, where we've got 9x plus 36 equals x squared, well, you would make sure to bring everything over to one side of the equation first. So I'll do 0 equals x squared minus 9x minus 36. Okay? And looking at this again, I'm putting it in the correct order from x squared to x to the power of 1 to no x. All right, so from largest to smallest degree, so going from 2 to 1 to 0. So x squared to x to the 1, x to the 0. And now I take a look at it and I say, well, what two numbers multiplied together give me negative 36, but the sum of those two numbers added together gives me negative 9. So that we have x minus 12 times x plus 3. And that gives me 0. Negative 12 times 3 gives me negative 36. Negative 12 plus 3 gives me negative 9. Now, because I've got x minus 12 times x plus 3, here is my null factor law, and it's set equal to 0, then I can go on now and say, well, either x minus 12 equals 0, or x plus 3 equals 0. And my final solution will go to x either equaling 12, or x equaling negative 3. So my answers would be, for the third question, they would be x plus 12 and x equaling 12 and x equaling negative 3. All right. The last example I'm going to use now is we'll do 6x squared plus 13x equals 5. So I will have 6x squared plus 13x equals 5. I'm just going to move this over a little bit so we have a little extra room to write. Okay? And we're going to have, now, because the value of the a here doesn't equal 1, then we're probably going to be using splitting the middle term. First, I'm going to check to see if there's a common term I can remove. So 6 can be removed from 6. 6 cannot be removed from 13. And if I bring the 5 over to the left-hand side, 6 can't be removed from 5. So I'm going to then use the splitting the middle term technique, where I say a times c has to equal 30, and my value of b equals 13. So I'll split the middle term into 6x squared plus 13x minus 5 equals 0, and the value, or AC, has to equal negative 30. All right. So I'm going to look for two numbers that multiply together give me negative 30, but those same two numbers added together give me 13. And it would seem that positive 15 and negative 2 would satisfy that. So I'll start removing, I'll do 6x squared, and I will do plus 15x minus 2x minus 5 equals 0. And now I have four terms, so I can split the middle term and remove a common factor of the first two digits, which is going to be a 3x, and I will be left with a 2x plus 5. And if I remove a negative 1 on the next one, the only thing I can take out is a negative 1, then what's left over is a 2x plus 5. And that's set equal to 0. So that either 2x plus 5 can be removed, and what's left over is a 3x minus 1. And that's set equal to 0. Now, the very last step that we have to work with is using the null factor law. And the null factor law basically is going to say either 2x plus 5 equals 0, or 3x minus 1 equals 0. So 2x equals negative 5, and x equals negative 5 over 2, or 3x equals 1, x equals 1/3. So there are my two solutions to this problem. They are either negative 5 over 2 or 1/3. All right. We're just going to do a couple of more examples, small examples, and I'd say that we're pretty much done. Now, if I have to bring everything over to one side of the equation here, what I could do on the first example is I could just multiply the two equations, cross-multiply across the equal sign. Okay, so that I will do 2 times x plus 2 is equal to x times x minus 1. And when I expand, I will do 2x plus 4 is equal to x squared minus x, and then I'll bring everything over to one side of the equation. So I'll do 0 is equal to x squared minus 2x minus 4 minus x. So that my answer will go to x squared minus 3x minus 4, and that will be set equal to 0. Now I'm going to be looking for two numbers. So I've brought everything over to one side of the equation. I have a quadratic trinomial, so I'm going to look for two numbers that multiplied equal negative 4 but added equal negative 3. And those numbers, I believe, are x minus 4 and x plus 1. All right. Now, once I know that x minus 4 and x plus 1 are multiplied to each other and they're set equal to 0, then I can just use the null factor law and say 0 is equal to x minus 4, or 0 is equal to x plus 1. And therefore, x will either be equal to 4, or x will be equal to negative 1. All right, and the last example, we can put this over 1, so that this will go to 2x plus 1 equals 3x times x, which goes to 3x squared. So I have 2x plus 1 equals 3x squared. Bring everything over to one side of the equation, 3x squared minus 2x minus 1. And so now, because 3 cannot be removed, a is not equal to 1, then I'm looking for two numbers that multiplied will equal 3 times negative 1, which is negative 3, and the value of the middle term has to be equal to negative 2. So I'm going to split the middle term here. So I get 3x squared minus 3x plus 1x minus 1. I break this in half, I remove a 3x, and I'm left with x minus 1 plus 1 bracket x minus 1. So that our final answer is going to turn out to be, removing a common factor, remember these have to be identical, it'll be x minus 1 times 3x plus 1, but that is still equal to 3x plus 1. But remember that these are still equal to 0, therefore we're going to use our null factor law. And we're going to say either x minus 1 is equal to 0, or 3x plus 1 is equal to 0, and x equals 1, or x equals negative 1/3. All right, that's it for today. We are not going to continue anymore. I just showed you here on this next page. So when we have x on both sides of the equation, we do not divide both sides by x. We bring everything to one side of the equation and set it equal to 0 when we are solving, okay? So x squared equals 5x. You do not do this. That's the wrong method. It's called illegal cancellation. And the correct method would be to bring everything over to the left-hand side of the equation and then removing a common factor. All right, removing a common factor and then setting it equal to 0 and then using the null factor law at the end. All right, I'm done for today. So what we're going to do is we'll take a look at the homework in class. See you next time.